Okay, I guess it's time to start. Hi, everyone. Thanks for coming. I'm going to talk to you about, like you can see in the slides, building a REST API using HTTP4S, abstracting over the effect type. So let's see what I mean with that. I'm going to start introducing myself. My name is Gabriel Volpe. Currently working at Paydi, quite active in the open source community, so you can check that out. And I really love functional programming. And yes, we are hiring, as you can see. We have a really cool team at Paydi, like very international, more than 20 countries. So I invite you to check our website and check the openings positions and come have a chat with me afterwards if you're interested, please. So this is the basic the agenda what I'm going to talk to you about. So because HTTP4S is built on top of FS2 and CutsEffect, I need to give you a quick introduction. Unfortunately, we don't have too much time to go like very deep into this concept, but hopefully you get a taste of what I mean. Then we're going to see the main data types in HTTP4S, how to manipulate JSON, error handling, streaming, and at the end, I have like a live demo prepared. So hopefully we have enough time to do it. All right. So let's get started with CutsEffect. This is actually like the hierarchy of type classes of the latest version that was actually published on Friday night, Japanese time zone. It basically allows you to define effects and to actually, for example, like define synchronous and asynchronous computations. And since the new version, we have concurrent and concurrent effect that lets you model cancellation as well. And we have like actually a really cool website that is actually, it's been published on Friday as well, so I invite you to check it out. It has a lot of documentation regarding the IO monad and all these type classes as well. So in addition to all this hierarchy of type classes, CutsEffect also provides the IO monad. How many of you have heard of the IO monad here? Please raise your hand. Good. And how many of you are currently using it? All right, so only a few. All right, hopefully after this presentation, all of you go run to your house and start using it because it's really cool. All right, so like all the functionality provided by these CutsEffect type classes are available in the IO monad because it implements all these type classes. It's the default implementation of CutsEffect. The other implementation is actually Monix task. It's actually the same guy working right now on all these projects. But you can do, for example, like you can just wrap a side effect in the context of the IO monad. And for example, printing a line to the console is a side effect of writing to the console. So with this, we are just saying, OK, IO represents the intention to perform a side effect. But it's not going to do anything unless like future that you say, future apply something, and it's going to submit that to the thread pool, and it started the execution immediately. Like this doesn't happen because the IO monad is referential transparent. And it's actually being equivalent to using the implicit sync type class. So you can say, OK, give me an instance of the sync type class for IO implicitly. And you just say .delay. That's going to suspend the execution of the side effect. They are equivalent, like the IO apply and sync.delay. And if you check the documentation, there is a bunch of useful functions to convert, like, for example, to lift a future into the context of IO. So like, I bet many people here are working with APIs that return a future. And if you actually want to model all your code using CutsEffect, you can integrate these APIs return a future very easily. And you can do it also abstracting over the type effect. You don't really need to use IO for this. Hopefully, I can show you that soon. And then we have FS2, which is a streaming library built on CutsEffect. And it's also pure, like, implements, like, all the API is actually pure functional. And that's why I actually encourage the use of, like, functional programming styles. And the main type is it's actually defined as a stream, which has a parametric f of a higher kind, and an I that stands for input. And there's two other types defined in terms of this main data type stream, they are just function transformation, as you can see. A pipe is just a function transformation from a stream of I to a stream of O, which stands for input and output, right? And a sink is exactly the same, but where the output is always unit. So it exists only for to represent the intention of performing side effects in a streaming context. So there's not going to be enough time to go into details on how F2 works, but at least want to show you the basics, and then we can go straight into HTTP4S and all the benefits of using it. So this is just a basic example of working with FS2 in streaming and also with the CutsEffect IO monad. For example, we define a source, it's a stream of IO in string. It's actually just a pure evaluation. We don't have any side effects. But we can define it once and actually reuse it anywhere. It just is referential transparent, and you can execute this many times, and the result will be always the same, right? So there's no side effects going around without us in control, right? So you can just compose this stream. A pipe is just a function transformation that will split the strings and get you back a list of strings, right? Very simple. And our sink, it's actually the input's going to be that list of string, and we're just going to go traverse that list and just print it to the console as a side effect. And as you can see, we are just wrapping that side effect in the context of the IO monad. And what we get at the end is just a stream of IO unit of the composition of all these small parts of a stream, right? And what we're using here is actually the FS2 DSL, like this through and to, it's giving a source of stream, pass it through the pipe, and give it to the sink. It's actually self-descriptive, I guess. And this gives you back a stream of IO unit, right? All right. I know that this is probably too much for people that are not familiar with this, but unfortunately, we have only 40 minutes, and actually the main topic is HTTP4S, so let's jump in. Okay, how many of you are familiar with HTTP4S or using it? That's great. Okay, as you might know, or for people that don't know yet, the main data types are defined these guys are really big fans of Kleisli composition, and Kleisli actually provides composition as a monad. If the F type has a monad instance, the Kleisli has also a monad instance for functions. So you can actually compose functions, right? And we have two main data types: HTTP service, which is basically roughly it's just a function from request to option T of F and response. So that's what Kleisli is saying there. And then we have also HTTP middleware, which is also a function from HTTP service to HTTP service. We're going to see a few examples soon. But basically, what these functions allows you, the HTTP middleware, is, for example, such a common thing to remove headers or add headers to a request for all the requests in your API, right? So you can create your own middleware and add your own headers, just in one single place, and you just compose it with the rest of your HTTP services. The current stable version is 0.18. But there's a lot of things changing internally right now. So as far as I know, in the last pull request, I think it's still not merged. But things are changing right now. So the signature is still the same. For example, HTTP service still has the same signature of Kleisli, but now it's been renamed to HTTP routes. And I know there's a few other things changing right now. So it's I have to keep following these guys, what they're doing. But let's jump into a real example of how we define what in Akka HTTP are the routes, right? There's actually no standard as far as I know. I like to define my routes as HTTP endpoint classes. And here we see the first example where we're actually abstracting over the effect, right? We have a parametric F, and we only require to have an instance of a monad for that F. So that's all we need. We don't need to, if you were using here just the IO monad, what I don't like about having, if you're not writing your code, abstracting over the effect, you will have IO everywhere, right? And with that, you lose control of that IO anywhere. I believe in types, and the types tells you a lot of what they can do, right? And if you have IO everywhere, that function can actually write to a disk and send bytes over the network and do anything, basically. But when we have a parametric F, we require the minimum to make it work. We just need flat map here. And I'd like to use the flat map cuts, the type class. So I normally use monad, as you will use in Haskell. So for this one, we say, OK, we just need a monad to do a flat map here and return a response. We are not going to write anything to a disk or send bytes over the network, right? That's what I like about this approach. And again, HTTP services are composable. They are just plain functions. They are classly, so you can compose them. So let's say you have different endpoints, like users, HTTP endpoint, languages, invoice, sales. If they all have the type HTTP service of F, you can just compose them with this operator that it actually comes from the semigroup K instance in Cuts. And this is how we actually start an HTTP server. So basically, what we're doing here, well, this is one of the recommendations, actually. We are using the Stream app from FS2 framework. This is actually going to run the HTTP service in a streaming context. And what basically lets you do, we just need to, I'm using the Blaze builder here because HTTP4S supports different backends like Shetty and Tomcat. But the default is Blaze. So I'm using Blaze, binding the HTTP to the port 8080, and then the local host. And I'm just mounting a service, which is the service I defined before. So this service here is an HTTP service of F. And it's just called .serve. That gives me a stream back. And again, I'm actually, this is the main server, and I'm already also abstracting over the effect. But in this case, I'm requiring to have, that F needs to have an instance of effect. And there's going to be only one place in my application where I actually define what this effect is. At the moment, there are only two instances available. One is CutsEffect IO monad, and the other one is Monix eval task. And so you can decide only in one place, right? And you can do the same thing for testing as well. HTTP middleware. An HTTP middleware, it's a function from HTTP service to HTTP service. And HTTP4S provides a few middlewares out of the box. So if you check the middleware package, you will see there's a lot to play around. But the most common ones, for example, that I use all the time is /, the cross-origin request, the CORS, and also a timeout, a generic timeout for all the requests. And you can compose them. And let's say we have, from the previous slides, right? If you compose all your HTTP services and you just have one single variable of HTTP services, then you can apply your middleware as a function application to all your endpoints, right? So all your endpoints will support /, and we have access. We will support the same timeout. So I find this super powerful, right? It's just functions. So you can reason about functions. Right, so most of us humans, we actually work doing REST APIs, and we normally exchange the data in a JSON format, right? You might have the request to do it in an XML sometimes, maybe, but the most common one is JSON all the time. But HTTP4S doesn't provide any JSON library out of the box. It actually just requires you to have an entity decoder and entity encoder for a parametric F and A. And fortunately, there's an HTTP4S-Cersei package that you can import, and it actually is the recommended library if you're using HTTP4S. It integrates very well with HTTP4S, and it also depends on Cuts, so it's very well integrated. And for example, you can define, there's no best practice for this yet, so you can actually define this implicitly in your package object of all your endpoints. You can just define a trait, or the way you prefer it. You just need this implicitly in the context where you're going to actually marshal in and marshal in your case classes to HTTP responses JSON, right? So in this case, I'm using the Cersei library. I'm omitting the imports here because it doesn't fit on the slide. But I will show you the code compiling with all the imports at the end. So error handling in HTTP4S, because HTTP4S is built on top of CutsEffect, then all the error handling is delegated to to the monad error instance, like that we've seen at the beginning. I don't know if you remember in the type classes hierarchy of CutsEffect, the first one was monad error, that it actually comes from Cuts core. It's the only one that all these type classes define in CutsEffect. It's extending. So for example, we can say, okay, I want to raise an error in the context of I/O. Don't confuse this with throwing an exception, right? It's not the same. We're just saying, if you remember the first definition, we are just, I/O represents the intention to perform a side effect. That's it. It doesn't run anything, right? It doesn't throw exceptions until you ask for it. That we normally do at the end of the word, what you call it's like the edge of your application. You're going to see that soon. One thing you can do is also the attempt method, is just to convert anything that might fail into an either inside your I/O monad, right? And that also comes from the monad error, as we demonstrate in the middle of the slides. We are just requiring the monad error instance implicitly, and we are doing exactly the same. So we can say the first part would directly using I/O, and the second part, they are equivalent, right? And one way to handle errors that's pretty common is using the handle error width. That it gives you the power to actually map your business errors cases into whatever. Like for example, I define a keep going, which I don't care about any non-fatal errors. I just want to log that something failed, and I just say, okay, keep going. I don't care about this failure. So you can do that. But the most generic case in an HTTP library is to actually map your business case errors into HTTP responses, right? Into the appropriated HTTP response. So let's say I just define like two case classes, a user not found and a user already exists. Like these represent my business errors. And what I can do is just like write, let's say I have this user HTTP endpoint and a given function that returns an f of list of users that can fail, right? So with this handle error width, like in case the request is successful, I just do a flat map, and I will just get the list of users, right? And I just say, okay, we'll actually return an HTTP response with the status 200. But in case this fails, I can just handle my business errors, and I can say, okay, in case of a user not found, I will just return in 404. In case of a user already exists, I return in 409, a conflict. So you can do this, and you might end up in cases where you actually need to repeat yourself so much. If you have many endpoints in your API, and you have to handle the errors per endpoint, you might end up like in some kind of repeating yourself, right? So because this is so common, it's actually what I find like as a good practice to do is just define your error handler as a generic one that all your endpoints can use. So let's say we can define this HTTP error handler, also abstracting over the effect. You can see that I only require to have a monad instance in scope. And I'm just mapping my API errors into appropriated HTTP response. That's all I'm doing. And then in my HTTP endpoint, in this case, I'm using like as an implicit HTTP error handler. This is like preferences. There is no standard. But in this case, it gets simplified, the code, right? The error handler will be delegated to the generic one we defined before. And you just can keep adding all your business errors and map them to a proper HTTP response. So again, that's it about error handling. Then streaming responses. This is probably one of the things I find more powerful about HTTP4S. It supports streaming out of the box because it's built on top of FS2, right? So let's say, for example, you have Doobie. Doobie is another library that integrates very well. It's also built on top of FS2 and CutsEffect. And it supports streaming out of any relational database. So let's say you're using Doobie as well, and you return a stream response because it's like really heavy. You don't want to return like 1 gigabyte of JSON, right, in one go because it will take ages. So you can use streaming in this case, and it's as simple as doing OK and your stream. I don't think anything could beat this. Like, this is amazing. OK, let's jump into some bit code. And I check how much time I have. All right, I have like 20 minutes. So. Any questions so far before we get into the code? No? All right. OK, first of all, I'm going to run the API. So you can see how the functionality looks like. I just can everybody see this? Yeah? Good. OK, I just started HTTP4S. I'm using the version 0.18. Oh, so I guess I have something here. Yeah. So I had a Postman client. So this is actually, it has only one user's endpoint. With, for example, I can just request all the users. It will return a JSON. I have some hard-coded data in the in-memory database. And I can interact with this API. For example, I can delete one that already exists. Or I can request, for example, mile7. So this user exists, so I get it to 100, 200 back. If I just request a user that doesn't exist, I get it 404 and a message username. The username ASD doesn't exist, right? So, but for example, I can delete the user. For example, this one exists right now, right? It's my user. I can delete this user, and I get a 204, no content, like a standard HTTP response for deleting. If I try to delete again, I get a 404, that it doesn't exist anymore, right? Yeah, I didn't code the update, but it would be really trivial to add it. So now I have only one user if I request all of them. OK, so this is like this is really a small live demo with only one endpoint, but it just you can get a taste of how it's written. I'm just gonna turn it off. So for simplicity, I wrote everything in one file. So it's like about 100 lines of code. I'm just going to start at the end. Is it clear? Everybody can see this? It's good size? Good. First of all, you can see there's a user repository that is abstracting over, it has a parametric f, and it doesn't have any requirements, right? It's just a trait, like similar to like a tagless final style coding. And I have just an implementation for this. It's just an in-memory user repository. And in this case, I'm required this f to have an implicit instance of sync. This means that this repository will be able to suspend effects in a synchronous way, right? The types are saying a lot. This is just an in-memory repository for demonstration. Right? This is probably what you would do for testing. But here, let's say you have a real database. And I have my small model here, like username, age, and in my user case class. And I have my exception, user already exists. So let's see how we compose all of these components, right? Here I have a user service, again abstract. It has a parametric f. And in this case, I'm only requiring this f to be a monad error, right? That's all I care. So this service, again, it's saying a lot, like just by the types. It requires only a monad instance being able to do flat map, and to handle errors. That's why we require a monad error instance, right? And in the case of find all and find, we just delegate that call to the repository. But in case like of persist and delete, we have some business logic here. We try to find in case of persist, we try to find the user. If the user doesn't exist, then we proceed to persist the user in the repository. So you can see here. If the user doesn't exist, then we raise an error in the context of f. That means that it's going to be handled by the monad error instance. Something similar happens with the delete. We try to find the user by username. If the user exists, then we proceed and we delete the user. Otherwise, we just return none. We just return maybe user, which is going to be none in the case of doesn't exist. So that's pretty much it in the user service. Here we see again that this trait is JSON codecs defining like the decoders and encoders as implicit. Like I have an extra 2 lines here just for make it work with value classes. But normally, if you don't use value classes, all you need is just this one, and you don't need this product here. It's kind of a workaround, to be honest. And finally, we have our HTTP endpoint here. Again, we have a parametric f, and we require that to be an instance of sync. And I actually did this on purpose. We don't need the sync instance here. The only thing we need here is probably a monad error instance, because we are using flat map, and we are using handle error width. But that's all we need. We need a monad error instance. But if you try to require just a monad error instance instead of a sync, this won't compile, because we are extending from the JSON codec straight. And if you take a look again here, this is requiring us to have a sync instance of f, right? But what I will normally do is write this in a package object as implicit, and avoid doing this, extending the trait. But if you play around with this code, I invite you to do that, and I try to compile this code. Always require to have the minimum working instance that you need, right? You don't need a sync instance here. You just need the monad error. So I leave that as homework. And as we've seen before, the HTTP server again. In this case, again, I'm using the stream app, and I create all the necessary components to start my user HTTP endpoint. And for example, I'm actually creating the repository, the service, and the endpoint. And you will wonder, OK, but if I have at least 10 endpoints, this code will go messy, right? You have really huge for comprehension initializing all your components. And that's true. So I like to program and to refactor my code as whenever I need it, right? So in this case, it's small enough, this implementation, and it's I need only one endpoint, so I wouldn't do much more than what I need. But if you have, the normal case, have more endpoints, I would just refactor this and create a module where you have all your instances, and you can compose all your HTTP services and your HTTP middleware. Yeah, and here this is actually a compiling live demo, so it's all the imports in scope. I'm going to share this code with you along with the slides. So I'm going to leave at the end a few minutes for questions. I'm almost nearly done here. OK, so here's the URL I actually updated before a few minutes ago. So I pushed already all the code. It's only one single file, right? To this GitHub repository, paid it talks. You will find the slides as a PDF as well. And still much more that unfortunately, in 40 minutes, 45 minutes talk, I don't have time to talk about everything that HTTP4S has to offer. But I like to enumerate a few of them. For example, HTTP client, it's one of the features that HTTP4S provides out of the box, and it also supports streaming. So you can create a client and do streaming, and create an endpoint that supports streaming, and you can do streaming all the way. And it's such a cool feature to play around with. There's more HTTP middleware, as I mentioned before, for example, CSRF, JSIP, and the guys are working on middleware for metrics, supporting Codahel, Drop Wizard, and some Prometheus, some other metrics libraries. It supports just basic authentication, basic and digest authentication out of the box. For more complex types of authentication, like JSON Web Tokens and bearer tokens, I really suggest to take a look into TSEC. TSEC is a security cryptography library that has support for HTTP4S, and it's very active in the open source community. So I really recommend it. And it also supports SSL and TLS, even though I don't really recommend managing the certificates and all the security in HTTP4S. I will do that at the level of the load balancer. And I think I don't remember exactly, but I know that the guys are working on HTTP/2 support. I don't know whether that's ready or not yet. So yeah, we are hiring, guys. We have a really cool team. So I invite you again to check our website. We have 3 different teams in in the backend, like core APIs and big data team. So if you're interested, please come have a chat with me afterwards. So this is the end of my presentation. I'll leave this time for questions. Yes?
Are you using HTTP4S?
Maybe can you use the microphone?
Are you using HTTP4S in production?
Yes. There's actually an open source project that I worked on in the last 6 months, and it's using HTTP4S, Doobie, CutsEffect, and FS2, and it's open source. I can actually share the links with you. Or if you go to my profile in GitHub, you will find it. And actually, at Payday right now, I are actually starting working on projects from zero, from the scratch. And that's all I'm using, HTTP4S, CutsEffect, like abstracting over the effect. This is actually what we're doing at Payday right now in the API team.
That's cool. Another question. I have a toy project in HTTP4S, and one of the dependencies is hard-coded to use ScalaZIO. What would you do in this case?
Now, I guess you are using an older version, or are you using the latest one?
The latest one.
The latest one, and you managed to introduce ScalaZIO in there? Don't know how you're doing that.
I mean, the dependencies, one of the dependencies is using ScalaZIO.
Oh, okay.
And I wanted to stick with the type level stack.
Yes.
So, I don't know how to do this. I don't know how to do it, so I just ran unsafe run sync inside CutsIO.
Yeah.
Would you do that?
Yes, I mean, that's the only way to integrate with other features, right? Or you can actually you can look at the implementation of I/O from future. That will say you actually the way you can actually lift effects into I/O. It's just like using the IO.async, and you can just, if you have a way to run that side effect or that effect like ScalaZIO or future asynchronously, then you are given a callback from. And then you can actually, if that is a successful computation, then you just return a right side of the callback. If it fails, you should return the left side, right, representing the error type. But you already lift that effect into your own effect stack, right? Yeah.
Thank you.
You're welcome. Any other question? Yeah, sure.
Thank you for the talk. We are implementing this pretty similar project using HTTP4S, FS2, Doobie, Cersei, etc. And now we are using IO Monad as their implementation of CutsEffect now. But there are some other alternatives, I guess. Is there any other choices you have, you have explored, or
do you mean choices to the IO Monad to use in
of the implementation of CutsEffect?
Yeah, at the moment, I mentioned it before. It's only Monix task and CutsEffect IO. These are the only two implementations. Oh, somebody wrote like the ScalaSet.io, like from the version the ScalaSeed 7, but I don't think that's stable enough, and I don't think it's updated right now. So I will actually recommend either using IO or Monix task. Okay. Actually, that was the question. Is
which one?
Yeah, which one is the best, right? And that's a question for Alexandru. There is a guy developing Monix and also CutsEffect at the moment. He gave a really good answer, I think, on Twitter, and he should write that down somewhere else in a blog post or something. But like the too long didn't read version is like, okay, IO, it's more conservative in that term. You, for example, you need to use thread shifting. You have to manage that yourself whenever you want to run concurrent and parallel computations. If you use Monix task, that comes out of the box. That it's handled by the Monix scheduler in the internal. So that's one of the differences. Like the short version is like Monix task is more powerful right now, but because the same guy is also working in CutsEffect now, since the latest version 0.10, it supports cancellation, it supports racing, so it supports parallelism as well. So it's like getting really
more similar.
It's getting really similar to task, but it's still, Monix task still like more powerful in that terms. Yeah, I will try to share the answer of Alexandro because he's the most appropriate person to answer to this question, right?
Thank you.
Yeah, you're welcome. So, any other questions? No? Okay, then thank you very much, guys.